In the last video, we explained the definition of push-pull circuit. Today, we will explain the difference between the two structures of upper N and lower P and upper P and lower N. We will mainly explain from the above aspects. First, let's look at the output circuits of the two circuits. As can be seen from the figure above, the phase of the upper N and lower P type output signal is the same as the input signal, and both are high level. The upper P and lower N type output is inversely proportional to the output. When the output is high, the input is low. The upper N and lower P type output voltage amplitude is generally 0.7 volts lower than the input signal amplitude. This gap easily causes the output amplitude to be limited by the input signal. Here it can be shown that this circuit has certain requirements for the input signal. Otherwise, because the input signal amplitude is too low, the level signal amplitude of the subsequent state is insufficient. Therefore, when the input signal level is too low, if the current output by the push-pull circuit is too large, it is easy to cause the upper N tube to heat up, and in severe cases, it will cause it to be damaged. For example, there are the following situations. When the push-pull circuit is used for signal control, the current flowing through it is generally not very large, so the upper tube is not easy to be damaged. When the push-pull circuit is used to drive the line, the current flowing through the tube at this time may be large. If the input signal amplitude is low, the upper tube will heat up seriously. At the same time, the lower P tube will also have the risk of heating. For the upper P and lower N type, it can be seen from the schematic diagram that its input and output are inverse. That is, when the input is high, the output is low. When the upper P and lower N type meets the saturation conduction conditions of the transistor, the output amplitude will be close to the power supply voltage. From the circuit schematic diagram of the upper P and lower N type, we can see that compared with the upper N and lower P, the upper P and lower N type has two more resistors, which will increase the cost accordingly. Then some friends will say, can't we just remove the two resistors? Of course not. As the saying goes, existence is reasonable. If the two resistors are removed, the upper and lower tubes will easily be connected in series, causing heat and damage. And we must also note that, under the protection of these two resistors, we need to pay special attention to the input end to always have a signal, and its amplitude will not cause the two tubes to be turned on at the same time. In addition, the slew rate of the control signal must be much greater than the switching speed of the transistor to prevent the occurrence of series connection during level conversion. The above is what we talked about today. The differences between the two structures are summarized as follows. Generally speaking, the upper N and lower P type has more advantages in the push-pull circuit. Therefore, in practical applications, the push-pull circuits we use are generally upper N and lower P type. Of course, upper P and lower N are not useless. If the upper P and lower N type transistors in the push-pull circuit are replaced with MOS tubes, many of the shortcomings will be greatly improved, and the performance will be optimized. If you have any questions about MOSFET product technical solutions, you can leave a message in the comment area. I will give you the answer here. VBsemi-MOSFET manufacturer focusing on MOSFET R&D and manufacturing for 20 years.